This question examines logical access controls in a client's server information system, specifically the risks associated with using a single sign-on (SSO) password. Single sign-on allows users to authenticate once and gain access to multiple applications or databases without entering separate passwords. While SSO improves convenience and reduces password management costs, it also introduces security risks if the single authentication credential is compromised. Students should focus on identifying the main disadvantage of relying on one password for access to numerous systems. If the single credential fails or is stolen, an attacker may gain access to multiple resources, or legitimate users may lose access to all connected applications. This concentration of risk is commonly described as a single point of failure, a concept widely used in information security and internal control.
A. Trapdoor entry point. Incorrect.
A trapdoor or backdoor is a hidden method of bypassing normal authentication procedures and is unrelated to single sign-on designed B. Single point of failure.
Correct.
Because one password controls access to multiple systems, compromise or failure of that credential can affect the entire environment, creating a single point of failure. C. Administrative bottleneck.
Incorrect.
Single sign-on generally reduces administrative workload rather than creating bottlenecks. D. Lockout of valid users.
Incorrect.
Although users may be locked out if credentials fail, this is a consequence rather than the principal disadvantage of the SSO architecture. Correct answer, B. Single point of failure. This question evaluates internal controls in an electronic data processing (EDP) environment, particularly the principle of segregation of duties. In a well-designed information system, responsibilities for system development, computer operations, data control, and custody of programs and files should be separated to reduce the risk of errors, fraud, or unauthorized system changes. The question asks for the weakness in the internal control system, meaning the situation that violates this principle. Students should recognize that operators should run programs according to authorized instructions but should not have custody or control over program libraries or master data files, as this combination creates an opportunity to alter programs or data without independent oversight. A. The data control group reviews and tests procedures and handles the reprocessing of errors detected by the computer.
Incorrect.
This is an appropriate responsibility of the data control group and supports independent processing controls. B. The accounts receivable clerk prepares and enters data into the computer system and reviews the output for errors.
Incorrect.
Although additional review may be desirable, this activity is generally part of normal transaction processing and is not the major control weakness presented. C. The systems analyst designs new systems and supervises testing of the system.
Incorrect.
Systems analysts commonly participate in system design and testing before implementation. D. The computer operator executes programs according to operating instructions and maintains custody of programs and data files.
Correct.
This is a significant internal control weakness because the operator has both processing responsibility and custody of programs and data files, violating segregation of duties and increasing the risk of unauthorized modifications or fraud. Correct answer, D. The computer operator executes programs according to operating instructions and maintains custody of programs and data files. This question tests knowledge of information security controls, specifically the methods used to protect confidential data transmitted over the Internet. When sensitive financial or business information is sent across public networks, organizations must ensure that unauthorized parties cannot read or alter the data. The primary security objective in this situation is confidentiality, although integrity and authentication are also important. Students should distinguish between technologies that protect the contents of transmitted data and those that perform other security functions, such as authentication or network access control. The control that directly converts readable information into an unreadable format, which can only be restored by an authorized party with the correct key, provides the strongest protection for confidential transmissions.
A. Single-use passwords. Incorrect.
Single-use, one-time, passwords strengthen user authentication during login but do not protect the confidentiality of data while it is being transmitted. B.
Firewalls. Incorrect.
Firewalls monitor and control network traffic entering or leaving a system, but they do not encrypt the contents of transmitted information. C.
Encryption.
Correct. Encryption converts plaintext into ciphertext using cryptographic algorithms and keys, ensuring that intercepted data cannot be understood by unauthorized individuals. It is the standard technique for securely transmitting confidential information over the Internet. D.
Digital signatures. Incorrect.
Digital signatures verify the sender's identity and confirm that data has not been altered, but they do not by themselves provide confidentiality.
Correct answer, C. Encryption.
This question tests knowledge of cryptography and encryption techniques used in computer security. Encryption is a process that transforms readable data, plain text, into unreadable data, ciphertext, to protect confidentiality during storage or transmission. Modern encryption systems rely on cryptographic keys, such as public keys and private keys, especially in asymmetric encryption systems like RSA. In addition, authentication mechanisms may use cryptographic keys to verify identity and message integrity. The question asks for the exception, meaning the option that is not an encryption technique or cryptographic key used in computer security. Students should distinguish between terms used in database management and those used in cryptography. While encryption keys are fundamental to information security, a database key serves a completely different purpose.
A. Public key. Incorrect.
A public key is widely used in asymmetric encryption systems and can be shared openly for encrypting data or verifying digital signatures. B.
Private key. Incorrect.
A private key is paired with a public key and is used to decrypt data or create digital signatures in public key cryptography. C. Primary key.
Correct.
A primary key is a database concept used to uniquely identify records within a table. It is not an encryption technique or cryptographic key used for securing information. D.
Authentication key. Incorrect.
Authentication keys or cryptographic authentication mechanisms are used in security protocols to verify identity and data integrity. Correct answer, C. Primary key.